Not guaranteeing that either. Okay, today we are doing 10-6. Parametric equations. And you wonder why sometimes we don't get to everything?
I don't know.
Crazy. Crazy. Hence why it's like something crazy happens and I pointed.
No idea what you're talking about.
It's Reese's Kick A, man. That kind of helps in the Kick A department. So hence why you're on the Kick B, you know?
Hey, the B.
Okay, so here's what we got. Here was our example from the Bell quiz. Hence why I made you guys do this. How are you? Yeah. Do you wear sunglasses? I can tell. Okay. So, with that being the case, we ready to go? Okay. We're going to graph this, but we're going to treat it in a different fashion. We're going to do parametric equations. Parametric equations, which basically introduces another variable into the equation that we have. So right now I have x's and y's, right? We're going to introduce another variable. I'm going to say x equals t minus 1. They use t a lot in parametric. Okay. What do you guys think y is then? I could see how you got that, but notice, look back up here. Wouldn't it be t minus 1 squared over 2 plus t minus 1? You guys agree? So therefore, this box represents a parametric equation. Notice x and y are in terms of another variable. Okay? What if I wanted you to graph this and I only gave you the parametric chart, not the rectangular chart? Well, instead of a T-chart like you guys did on number 1 of the Bell quiz, we're going to do a pie chart. Not really the kind of pie chart you're thinking. See, doesn't that look like pie? Shush your mouth. Okay. So notice, though, I'm going to plug values in for t. Oh, I forgot to say that. Usually, notice, didn't we have something up on this one? Didn't we say x was between 10 and 0 on our Bell quiz? So what is x, though? It's t minus 1, isn't it? So what is t? T is in between 1 and 11. Because I have to add 1 to every side. Add 1 in here, gone. Add 1 to here, now that's 11. 1 plus 0 is 1. Has everybody got where I'm at on that? So we have now our same restrictions because we want the graph to look exactly the same, don't we? We don't want to introduce other variables that or values that weren't allowed in the first time. Okay? So notice I can only use values, excuse me, not 0. 1, 2, 3, 4, 5, 6, 7, all the way to 11. You love me. Not everybody, but it's okay. I don't mind. X, remember, was t minus 1, right? So if I plug 1 in for t, 1 minus 1 is 0. Plug in 1 up here, 1 minus 1. 0, 0 squared, 0, 0 divided by 2, 0, plus 1 minus 1, which is 0. This comes out to be 0. You guys see how I got the same coordinate that we had the last time? 0, 0. Okay, now I'm going to pick 3 just so I can keep them a little nicer, because 3 minus 1 is 2, 2 squared, 4 divided by 2, 2, 3 minus 1, 2, 2 plus 2 is 4, 3 minus 1 is 2. So roughly like right there. Okay, and then I'm going to pick 5. 5 minus 1 is 4. 5 minus 1 is 4. 4 squared is 2. I mean, oh my hell, 4 squared is 16. 16 divided by 2 is 8. 8 plus 4 is 12. Paige, are you taking math next year? How about 1050? How about 1050? I just looked at my rolls and I need some more people in my 1050 class. Number 7, plug your 7 in. That's a 6 because 7 minus 1. Does everybody see where I'm putting there? You guys see I'm just plugging t values into the equation and getting the x's and y's? Okay, so that's 6 squared, 36 divided by 2 is 18, plus 6 is 24. Oops, I forgot to do the 12. 24. If I plugged in 9, I'm going to put 9 right here. That's 8 and 40. Sorry, we've already done this, so I'm going to just kind of pick it up, and then this becomes 10 and 60. You guys see how I got the same values as what was previous? Did you finish up? Okay, the only thing different, set it right here for me, if you'll staple it for me. Yeah. What'd you get? Plus 10, yep. Just because it's not into the fraction. I know. I know. I know. You did really well, though. I was really impressed on your test. Good job for you. The only thing that's different, guys, on this graph via the other graph is we have to say this is when t was 1. This is when t was 3. This is when t was 5. And so on. This is when t was 11. You guys see what I'm saying? Any guys done physics? I've never taken physics or chemistry, so I don't know. Well, I've taken chemistry. Okay. I've taken chemistry. I took it in college, and then that's why I'm not a physical therapist, because I do chemistry. So I was taking chemistry, and I don't remember where, but somewhere they talk about particle movement in physics or chemistry, and I don't know which one. But this is kind of an explanation of particle movement, because we have an equation of a particle, right? Maybe. And then we see the direction it's moving. So sometimes we also put these arrows on there to say, this is the direction it's moving. Does that make sense? I can't remember which one. It's in one or the other. More physics, probably. Does that make sense, though? Yes, Chuck. It just shows you the direction it was traveling. So instead of just a graph, it's saying, hey, we started here and we ended in that direction. Okay? From our t values, these are the values that made that t. This is the direction it was moving. Okay? On our next problem, I think you'll see it a lot nicer. Do you mind if we go on to the next one and then see it? Okay. The next one is x equals, I got to remember, oh yeah, t squared minus 4, and y is t divided by 2. Okay, where t is between -2 and 2. Not necessarily. Let's go to my pie chart. It's not a circle. I thought it was funny. Maybe you didn't. I had a meme. You guys should see this meme. I put it all over Facebook because it is my worst part of being a teacher. Hold on. Hey, that's my niece. She got engaged yesterday. Yeah, isn't that sweet? Even though I didn't do all my other work, I want extra credit. I'm just saying. Anyway, that's the only reason why I hate teaching is right here. Is because the end of the term. That's the day every time I'm like, why am I not an accountant? How do you know what I make? That's what you get for assuming, huh? Maybe. Did we? Not accurate. And? My benefits are not within 110. Yep, that would be higher on that level. Just saying, don't throw it. You got to learn how to make money within a system, Mr. Templeton. Okay, here we go. So if I plug in -2, what's -2 squared? 4. 4 minus 4? 0. Plug in -2. -2 divided by 2? -1. Yeah, that's a parametric that have the same variable within them. No. The last example that we just did? At the beginning. But sometimes they just give you the parametric. I was trying to explain. Yes, I can. We'll do that in just a minute. You guys, let me take, damn it! Did we not see that beavers can say damn it? Right? We might have to draw the darn picture.
Are you a beaver? Are you a beaver?
Okay. -1. -1 squared is 1. 1 minus 4 is -3. Plug in this one, it's -1/2. So I might want to put t equals -1 here because I want to talk about the direction again. This is t equals -2. Okay. Plug in 0. 0 squared is 0. 0 minus 4 is -4. 0 divided by 2 is 0. So that's right here. That's when t is 0. So notice, do you guys see there's a direction happening? It's telling us the way it's moving in this case. Does that make sense to you, Wyatt? So I start here, so therefore it's going in this direction. Yeah. Does that make sense? Exactly. So this is -3/2. And notice, hopefully you guys see I'm just plugging values in for t, right? And then I plug in those values of t into x, the equation for x. Yes, yes. And then this is 0, 1. Say again, I'm sorry, sir. Yep, you do that a lot. It is a parabola. It's just a parabola. It's a y-squared parabola, though.
bring this up once before.
I'm just going to take a deep breath again. Okay, now something really quickly. What would be the domain of this graph? Like she said, it's just a sideways parabola, right? What is the domain of this graph? So what's the x values that I've used? Negative, not infinity, because I had to stop, right? Oops, sorry, you made me write freaking infinity. It is 0. Because notice I stop, the farthest this graph goes is over to -4 and we stop at 0 because our restrictions based us on that, right? Now what's our range? How low did we go? -1. How high did we go? 1. So that's restrictions on that as well, right? So now we're going to move on. Now, using these same equations, we're eliminating the parameter. What does that mean? We're getting rid of the t. So it's just in x and y. We could also call it putting it in rectangular form. Because rectangular form is just x's and y's. Okay? So, all I have to do is solve for t. It doesn't matter which equation. Is there an easier equation than another, though, to solve for t? Which one? The y. 2y equals t, correct? Now I'm going to substitute that 2y in for t. So I have x equals 2y squared minus 4. All I did was substitute in. So therefore x equals 4y squared minus 4. If I just left it this way, would I get the exact same graph? Yes and no. Yes, I would get the graph that covers those points, but it would continue to infinity because I don't have any restrictions right now, correct? Who's kind of being more of our input in this equation? The y is, because that's not solved for, right? X is being solved for, so therefore I'm going to restrict my y, and that's why we did the range, because there wasn't our range in between 1 and -1, so it helps us in our restrictions. So this would be eliminating the parameter. I have no other variables, just x's and y's, right? And I want to have the same result as I had in the previous one, so if I need to restrict, I could restrict. Okay? Chuck. Yes, but this is not the same. We're not going three-dimensional. Yeah. This is just giving us more of a direction. Okay? Yes. From the range. No. So just you would have to understand it's in parametric, and it already kind of restricted us because it was in between, t was between -2 and 2. So because of that, what happened? Well, that restricts my y. And I can show you how that works, because right here, here's our restrictions, right? What did we know y is? T is 2y, so I could write this. It was in between 2, t, which is 2y, and -2, correct? How do I solve for y right there? So doesn't that basically become that? With me? It is restricted. Isn't the graph, the lowest it goes is -1, the highest it goes is 1? Nope, that's t is 2, and t is -2. But notice this value right here is 0, -1. Right? Does that make sense? Everybody good? Does everybody understand where this came from? What if I had y's in terms of x's? What if that came out? I would restrict the x's, wouldn't I? And what would that probably be? It'd be the domain, wouldn't it? Does that make sense? Okay. All right. Here's another one. I wonder where we've seen this before. We just barely did it, so I guess it's not that hard. I showed you how to do it. Huh? You can. It can. Was there like a smirk? I'm just making sure. You probably give me the dirtiest looks out of everyone in this whole class. I think it's the funniest thing. A guy just gives you a nice little, recommendation to get a job, but then we get dirty looks the rest of the time. You have one of those faces, huh? Resting. Yeah, that face. That's not your resting face. No, it is not. Always seen. Which one is easier to solve for? We're going to eliminate the parameter. Notice there is no restrictions on the parameter, so am I going to have to restrict at the end? No. Okay. You think X, I believe when we did it on the Bell quiz, wasn't X easier to solve for? You are such a liar. You are too. Mm-hmm. Yeah, you're thinking. Your resting face is when you're not even noticing what's happening. Just say okay. Just say okay. Just say okay, Alkeburger. Yes, sir? What did I do this time? I did? What did I say? I guess it might pop out and I don't even want to know. So,
I didn't hear it either.
Me neither. I wonder if the video caught it. Which I don't care if it caught. I'm just solving X or Y. It doesn't matter. Once again, I'm just solving for T because I'm eliminating the parameter. Yes, ma'am. Now remember, it also looked like this. Some of you guys could have had this. Each of these will work out, so it doesn't matter. I squared both sides. Then I flipped the fractions. Then I went ahead and subtracted 1. Or are you asking the bottom? I got a common denominator. Right here, see? X squared over X squared. Wasn't that 1? Sure. Sometimes you just want to have a denominator because when you have fractions and you're subtracting fractions, we want common denominators. Hi. No. Because now, to be honest with you, what are we going to do? We're eliminating the parameter, so what are we going to do? We're going to plug it back into the y, and either of them will still get us the same result. Okay, so then I come back down here. Let's go ahead and use this guy. So that is 1 over x squared minus 1 over 1 over x squared minus 1 plus 1. And I'll do the other way just to show you that it still doesn't matter. But notice if you solve differently, you could get both of those answers. That's another reason why I wrote both of them. Because if I times this over to the other side, you know what I mean? I'd get x squared t plus x squared. So I subtract the x squared over, then I divide. That's why I get the other one. Answer your question. Let's simplify this though. Notice this becomes right here, ladies and gentlemen. What does that become? Just 1 over x squared, right? Do we like fractions over fractions? So we're going to times the top by x squared and the bottom by x squared, because what's that? 1, can I just do that? Yes, I can. Because it's equivalent, right? So what happens here is this cancels out, so I just have nothing on my denominator. Well, I have a 1, right? What does the top become? So I distribute it through. That becomes 1 minus x squared. So it's just a parabola. Those two together are just a parabola. So if I was graphing it really quick, whoop, whoop. This y, coming back up. I just plugged that, because I solved for t here, see that? And then I just plugged it in for the t's, right? Does that make sense, Cal? Good. I'm not going to spend time because we only have 15 more minutes. I still got a little bit to do. But I could plug the other one in and I'd get the same result. Okay? Is everybody good with me? All right. Now, not everything's nice. Maybe they don't have t's. Maybe they have thetas. Oh, nuts and crackers. This is the hardest thing ever. No! That's what a lot of you do. Another pie chart. But what are we going to use for thetas? Why are we whining? Huh? How about 0? Yay, what's cosine of 0? 1. 1 times 4. 4. During the fire alarm, I was teaching this outside on one little piece of paper. It's very small. Because we didn't have time. Then if I plug in 0, sine of 0 is 0. 0 times 4 is 0. So right here, so far, here's our location. 1, 2, 3, 4. Let's plug in pi halves. Cosine of pi halves. 0. 0 times 4. 0. Sine of 0. I mean pi fourths. Pi halves. Damn it. Darn. Beavers. Okay. Sine of pi halves is 1. 1 times 4 is 4. Notice we're still kind of showing a direction, aren't we? Because notice we started here. We went to there. Notice. And then I'm going pi, and I get -4, and I get 0. Then I do 3 pi halves. I'm not showing you guys. I'm just plugging them in now because I think you get the understanding where I'm getting these from. Right? Do you guys agree? Do you really not? Here we go. Watch. 3 pi halves. Cosine of 3 pi halves. 0. 0 times 4. Hence why it's 0. Sine of 3 pi halves. -1. -1 times 4. Are you good? Hold on. Nope. Nope. Oh, well, hold your ponies. That's why I said ponies. I bet your little sister has some My Little Ponies hanging around. I loved me some Applejack. She was always kick-A. She was kicking people. Hey, there it is. It's a circle. Could it still have direction? As you graph it, it could be direction. Or as a particle is moving, it's going in a direction. Exactly. Do we not give directions of that all the dang time? Thank you, Kelsey. Sometimes. Oh. Okay, onward. I don't have time to argue today. So, we saw it as a circle. Let's eliminate the parameter. Who's our parameter in that case? Theta. We want to get rid of him. We only want x's and y's. Okay? Because that eliminates the parameter. Therefore, it's not in parametric anymore. It's now in rectangular. On your calculator, guys, if you hit mode, there is a parametric mode. Not that I'm going to really use that, but just be aware, there is one. Could be. Okay, I'm going to continue on though. Here we go. How I eliminate the parameter. Okay, how I eliminate this parameter. Whenever I see cosines and sines, I'm going to square it. You'll see why in just bear with me. Now you guys have studied circles, at least you should have last year. Okay. In secondary 2 honors, it's part of your core to talk about ellipses, circles, hyperbolas. Okay. You should have. I'll go there. You should have. Okay. Now, the reason why I squared this, watch what happens when I square this and then I add the rows together. First off, what do these two guys have in common on the right-hand side? 16. Cosine squared plus sine squared, we can eliminate that or eliminate the parameter by saying sine squared plus cosine squared is 1. So therefore this is equivalent to x squared plus y squared equals 16, which is an equation of a circle with radius 4. And isn't that what we graphed? So therefore shouldn't our equation graph that same type of an idea, right? You're more than welcome. I'm just showing what you can do. Why not? That's exactly what we're trying to show. Hey, what about this guy? Okay. What about this one? I personally want to get that 4 over on the left first. Then I'm going to square them. Then what do you guys think we're going to do again? We're going to add them. Don't eve them. It's all right, A. It's all right, Chuck. And here comes Bradshaw. Just like a whole lap behind. So when we add these together, now you might have to subtract these or you might have to do some other things. If you subtract it, it'll become a hyperbola. Okay. And here's our graph. Remember, this shifts us to the right 4, up 3, with our radius of what? 1. You just take the square root of the other number. On the right-hand side. Pretty good? You guys remember somewhat of the circles though? By the way, here's your basic equation of a circle. X minus h squared plus y minus k squared equals r squared. Okay, so therefore hk is your center, where r is your radius, right? Okay. A hyperbola could be x or y leading. It doesn't matter. So I could have x minus h squared minus y minus k squared equals, by the way, this has a squared and this has b squared. This is 1. This one looks like this. If your y is leading, then it's up and down because it's eating the y-axis. That's how I remember. The monster's eating the y-axis. The monster's eating the x-axis. That's how I remembered it. Yeah, kind of. I don't know. That's just how I remembered it. Okay. But we're not really going to get too deep into that stuff. The circles, probably. I don't know about hyperbolas and stuff. Okay, your homework is maybe. There it is.